So we're going to take a look at stationing along a preliminary traverse. This is an actual road, and I've got the design plans for it. So we're going to use this one. We're going to look at 3 horizontal curves and see how you'd actually move from the starting point, which was giving a station of 10, to the end point. And so we'll go through 3 different horizontal curves, and starting with just looking at the tangent. So likely what happened in this design process is the crossing of the railroad tracks was an important point, and so they said we're going to try and cross that at as close to a 90-degree angle as possible. And so the first tangent was probably just drawing a line at the point that they wanted to cross those railroad tracks, and extended that end until they hit other obstructions. In the southern point, it was likely this residential property, and the northern part of this dealing with the actual building and parking lot and facility itself. The next tangent that was probably a consideration was this first one, and the goal was to create as close to a 90-degree intersection as possible. So that'd be our 2 tangents really are kind of on the design control side of things, of trying to line up with obstructions or obstacles in this area. And then we have another tangent that will connect those 2 tangents, and then our final tangent taking us to the end point of this alignment. So these are the 4 tangents that we're looking at in this example that we're going to go through the stationing exercise for. And so let's actually go ahead and jump in and look at our first curve, and we're going to have our starting point at station 10. And essentially what we're going to do is we're going to need to establish the points of intersection. So that's essentially what our goal is for our preliminary traverse, is to establish our points of intersection. So we'll know the stations of all of our PIs as we move through this, but we have to establish one curve at a time and then move to the next PI in order to correctly establish those PI stations. And so we'll see this is the important reason. This is the reason why the PI is such an important component for horizontal curves. The red line here is establishing the tangents, and in particular the center lines of the roadway. And so what we do is we have our starting point here. It's going to be in the center line of the pavement, so that's why we're kind of in the middle of that turning lane. And what we're going to need to do is measure this tangent. So we're going to just take our measurement, and we calculated a length of 357 feet. And so our first PI of curve number 1 is going to be at station 13 plus 57. And it's going to be our starting point plus that distance of 357, so that'll give us the 1357. And it should be right where these tangents come together for that point. So we also have some information from the design files about the curves, and that information for our first curve here is that the tangent length is 278 feet. And so to establish where our first PC is, we need to come back from the PI 278 feet. And so our PC is going to be somewhere in this point here. So that's going to be our first PC, and there's a pen drop to show us where that is. Now we can also establish our PT station, or our PT location, not our PT station, with that tangent length. So if we measure similarly 278 feet along our tangent, so it should be right in that point, and we can turn on, I've pre-populated these points. So there's our PT1. So we have our PC1 and our PT1. Now we know the center line is going to need to follow the center line of the roadway, not along those tangents. So our actual road itself should be splitting the pavement and tying in our PC and PT. So I'm going to try and change this to match with the other one. So what's going to happen is our tangents are going to be changed. And they're no longer going to connect all the way there. Oops. So that tangent would be adjusted there. So now all we're doing is modifying these tangents so they actually connect in to our center line of the roadway. So now our first curve looks like this. We've removed this piece of the tangent we don't need. We've got our first small section of the roadway that's going to be a tangent. Then we immediately start in our first curve. It goes from PC1 to PT1. We've identified the PI at station 13 plus 57. And then we have our curve here at PT1. So we're also going to need to calculate these stations as well as we move along this traverse. And so we started with our PI, we started with our starting point at station 10. And then we moved along our corridor. We measured the distance from that starting point to PI1, and we found that was 357 feet. So our PI station was 13 plus 57. Now we're going to subtract off the tangent length, which I told you was 278 feet. And for this, I'm just using round numbers. We can be more precise if we were actually designing this road. I just want to illustrate these distances. And so that gives us a PC station of 10 plus 79. So we got that from starting at the PI 13 plus 57 and subtracting off the tangent length of 278. So we also know from our design parameters, and this would have happened kind of in the background, the length of this curve is 508 feet. So to find the station of the PT, we need to add 508 feet to our PC. So 1079 plus 508 gives us a station of our PT1 of 15 plus 87. So that's our PT station. So next we can move along and establish our PI2, the station of our second point of intersection. So that occurs right here. So PI2, and we're going to have to determine what that station is based on the distance from PT1. So we're going to measure from PT1 to PI2, 689 feet. So PI2 is 15 plus 87 plus 689 will give us a station for PI2 of 22 plus 76. So we'll update that. 22 plus 76 is station for our PI2. So we know also our parameters for the second curve. Our tangent length is 350 feet. So we're going to subtract off 350 from our PI2. We can measure that. So we're going to go back 350 feet to establish the PC of this curve. And again, I pre-populated these. So there's PC of curve 2, and subtracting off 350 feet from 22 plus 76 is going to give us a station of 19 plus 26. We also know the length of curve 2. But before we do that, let's also measure out the 350 feet to just establish where PT2 is located. So 350 feet, it's going to be somewhere in this area. I'm going to turn that point on. So there's our PT2. The length for this curve is 679 feet. So we're going to add the length to PC2, 679 feet, is going to give us a PT2 station of 26 plus 0.5. So our PT2 is this station. Now what's going to actually happen at this point, the road's not going to follow the tangents, it's going to follow the center line of the roadway. So if we actually, again, draw in curve 2, it's going to follow the center line of the roadway. And of course, in a real design, we wouldn't have an existing road to draw on top of. But in this case, we are using this as an example. And so we no longer need those portions of the tangents. So I think I removed the whole thing. Let me zoom in here to see if I can edit this. Maybe easier for me to delete the tangent and then redraw it, or let me move some of these elements a little bit. So it would move this point. Oops. So this is the way the actual roadway would tie together. At this point, there's our PC2. Now we need to adjust this tangent on the other side to have it lining up with PT2. So our PI still happens kind of out there on that section, but now we're smoothing out these tangents. We're connecting them with those curves. So we start with that short tangent section. We had curve 1, then we have another short tangent, then curve 2, and now we have this final curve after a long tangent that crosses the railroad bridge. So we need to establish what the station of PI3 is, and we'll go ahead and drop a point here. This is going to be PI3, and we're going to establish its station by measuring the distance from PT2 over to that PI. And again, we'd be more precise if we were actually doing a design, but this is just for illustration purposes. So that tangent, or the distance from PT2 to the PI3, is 1,192 feet. So we're going to add that to our PT2. And so our PI3 is going to have a station of 37 plus 97. And we also know from this, the information we have for this curve, that the tangent is 151 feet. So pretty short, pretty small curve. So we're going to subtract off 151 feet from our PI3 to locate our PC1. So our PC1 is, our PC3 is going to happen somewhere in this area. And we're also going to establish the location of our PT3, so somewhere in that location. We can find the stationing, the station of PC3. We're going to subtract off 151 feet from PI3. So when we subtract off 151 feet, we're going to get station 36 plus 46 for PC3. We also know the length of this curve, which is 280 feet. So we're going to add 280 feet to our PC station. That's going to give us our PT station. So our PT for curve 3 is 39 plus 26. And the final thing we can do if we want to have our smooth path here for curve 3 that actually follows the center line of the roadway. And draw this in. So there's curve 3, and if we want to show reducing the lengths of these tangents, we can do that as well. So tangent 3 will tie in there at the PC. Tangent 4 will tie in at PT3. And then we can measure also the distance from PT3 to where we have listed as the ending point. That's another 66 feet. So we can add 66 feet onto our PT3 to get an ending point of station 39 plus 92. So we'll add in that information, 39 plus 92. So if we're looking for stationing along this preliminary traverse, we started with tangent sections. Obviously, our whole roadway is not going to be full of those tangent sections only. We're going to have curves to smoothly connect those tangents, and that's what we've added in. So we had this short tangent starting at the starting point of station 10. Then we have our first curve that we added in, starting with a PC of 10 plus 79. We added a curve length of 508 feet to get to PT1 of 15 plus 87. Then we had a short tangent to locate us to PC2 of 19 plus 26. We added a curve that was 679 feet long to take us to PT2 of 26 plus 05. We added a long tangent over the railroad tracks, which helped us establish PC3, and that is at station 36 plus 46. We had a pretty small curve there with a length of 280 feet to give us PT3 of 39 plus 26, and then again a final tangent at the very end to give us a final ending point of station 39 plus 92. And as we went along, we needed to use those PIs to establish those stations, and then we would subtract back the tangent distance and then add the length of the curve to establish that stationing along the full curve. And so this is how you would move along a traverse with tangents to establish the actual curve stationing for your horizontal alignment. So it's this incremental process. You've got to move from one curve to the next to establish the PI station, come back to establish the PC station using the tangent distance, and then moving along the curve, that length of curve to establish the PT, and then starting from that PT station, moving to your next PI or point of intersection to complete your horizontal alignment.